Alright, good morning everyone. Big happy Monday. Seems to be super lively. So many people here. Alright. Well, last time kind of had a short class, cut a little bit, and we were just talking about nonlinear systems of equations and what that kind of looks like and how we can go about solving those. So this was one of the examples that we did and went through. And so we just see it's like a system, a normal system where it just means multiple equations. But this time we're dealing with systems of conics. Okay, so we have like some squared terms, x's and y's. So it becomes a little more for us to do. Okay, when we eliminate an entire, try to eliminate an entire variable. And we might get, for instance, like 2 answers, maybe even 3 or 4, maybe 1. It's hard to say exactly. But let's just kind of move on. I have 2 more examples for us just to finish off what we normally would have done on the last class period. And then besides that, really have nothing else. So hopefully it shouldn't go too crazy long. So let's start it off. I have my system here. And so we have to decide first, do we want to eliminate the x's? Do we want to eliminate the y's? It doesn't particularly matter which one. Usually there will be an easier option. And so we might be able to see now as we look at these that my x terms, so there's my x squares, and there's my linear terms of just x. They're already set up in a nice, perfect, having the opposite sign coefficients, right? Positive 1x squared, negative 1x squared. Positive 12x, negative 12x. So actually this works pretty nice for us. The sun is in my face. Let me fix this. Okay, that's better. So I don't even need to go ahead and multiply anything. I can just add these together already. Okay, so add. We go through column by column. X squared plus negative x squared, 0. 2y squared plus y squared, 3y squared. 12x plus negative 12x, 0. 16y plus 8y, 24y, and then 50 plus negative 29 plus 21 equals 0. Now I need to solve this equation. So this equation is just a quadratic, right? It's a trinomial. So we have various methods we can try if we need to. First step is always try factoring. If not factoring, maybe complete the square. If we have to, if we're absolutely desperate and it's the worst of times, then we can go through and use a quadratic formula, but hopefully not. So here I see that I can do some factoring, I think. I'm gonna at least try. I see I have a GCF of 3, so I'll go ahead and factor out the 3. And this trinomial I can actually factor. If I'm looking for 2 numbers that multiply to make 7 and then add together to make 1, or sorry, not 1, 8. So it would be y plus 1 and y plus 7. Set each factor equal to 0 and solve. So y equals -1, y equals -7. Again, remember that even though there is this 3 out here, that does not mean that we should get y equals 3. Okay, if anything, because we're setting everything equal to 0, so that would mean I would do 3 equals 0, but that doesn't make any sense. So we don't need to do anything with just a coefficient in front. It's only if there's like some sort of variable, x or y, or something that I can actually solve. But if I just set 3 equal to 0, that does nothing for me. Actually, let me just undo. All right, so these are my two values right now, y equals -1, y equals -7. And so I need to plug in both of those in. Well, I need a case where I plug in one, a case where I plug in the other. How would we use the quadratic formula in this situation? So, good question, Jacob. So if I just had this, I could roll through the quadratic formula of, so instead of x equals, so y equals -b plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. So it would just be the same exact quadratic formula that we're used to using, except instead of x, it's y, but it's still the same exact setup. Does that answer your question? Maybe. US. Okay, cool. Yeah, but luckily for this one we can factor. I think usually we'll be able to factor, but just know that if you're not able to factor it, you could use the quadratic formula. So now we'll break this down. We'll go back to one of our first equations. It doesn't matter which one. Let's just use the first one. So x squared plus 2 times y squared, but I'm going to plug in -1, plus 12x plus 16y, but I'm going to plug in -1, plus 50 equals 0. Okay, so this is just me plugging in y equals -1. I'm not doing anything with the y equals -7 yet. I will, but not yet. Let's just do some simplification. -1 squared is 1 times 2, so plus 2. 16 times -1 minus 16 plus 50 equals 0. X squared plus 12x. 2 minus 16 would be -14. -14 plus 50 plus 36. Okay, so yeah, I mean, I kind of went through that quickly, but it's just doing the combination of like terms, and mostly just with the constants, right? Evaluating, multiplying the -1, or doing the squareds or whatever, and then just adding stuff together. Okay, x squared plus 12x plus 36 equals 0. So my goal is hopefully that I can just factor this. Right, I don't need a GCF of any kind. Factors of 36 that would add up to 12, so that would just be 6 and 6. or x plus 6 quantity squared. So I would get x equals negative 6. Now remember, I got this whenever I plugged in y equals negative 1. So I'm going to put my first solution is the x value is negative 6, the y value is negative 1. That's the first solution I have, but I'm not done. So now I need to go through and I need to do the same thing but now I need to plug in y equals negative 7. So I'm going to take that first equation again, just the same one I did before, and now I'm going to plug in y equals negative 7 instead of plugging in y equals negative 1, and this will give me my next point. So I'll go over here, x squared plus 2. I'm going to have to do a lot of scrolling because I can't remember anything. Negative 7 squared plus 12x plus 16 times negative 7 plus 50 equals 0. Does that all fit on the screen? Just barely. Okay, cool. And just like before, so this step is just simplifying. Negative 7 squared is 49. 49 times 2 is 98. 16 times negative 7, negative 112. And then plus 50 equals 0. Let's just combine all the constants together. So the 98, the negative 112, and the 50. X squared plus 12x, 98 minus 112 plus 50, 36 again. All right, well, notice that we ended up getting the same thing, so I don't need to go through the same process of, I know what will happen when I factor and when I solve. So again, I will get x equals negative 6. So x value negative 6, y value negative 7. All right, because we started by plugging in y equals negative 7 up here, and that got us x equals negative 6. So that means our final, well, we have a pair of solutions now. And then I do a really efficient boxing method like this to show that these are the final answer. Negative 6, negative 1, negative 6, negative 7. I showed you guys on last week's that, so what this is where these two conics intersect, right? When we solve a system, if we're thinking about that as a graph, it's just where there's curves intersecting with each other. So if we looked on the graph, we would see that at negative 6, negative 1, and negative 6, negative 7, these are intersecting each other. Again, kind of a coincidence that we ended up with x equals negative 6 for both. Don't expect it. always. Right? It'll depend on how you go about solving the problem. Sometimes it might, but sometimes it might not as well. Okay. So let's go to our last option. So I have this system. And again, as I look at these and I try to decide what variable is it that I should eliminate, should I eliminate the x's, should I eliminate the y's? Well, we have a good choice laid out for us here, in that we have y squared, 16y, 16y. So they're not opposite signs, but at least they're the same. So that will help us a little bit. So I'm just going to pick one of these. It doesn't matter which one. And I'm going to multiply it by a negative. So let's say multiply this by -1. So that would give me negative 8x squared minus y squared plus 32x minus 16y minus 23 equals 0. Okay, so that was just took that whole equation, multiplied it by -1. This first equation, I don't need to change it all, so I'm just going to write it down exactly how it was. It stays exactly the same. Just bringing them down. Now I'll add these two together. X squared plus -8x squared, so -7x squared. Y squared minus y squared, 0. -4x plus 32x, so plus 28x. 16y minus 16y, 0. 58 minus 23 would be plus 35 equals 0. Right, just column by column, make sure everything's lined up nicely. It shouldn't be too bad. Now we want to solve this. It's a quadratic, so let's try factoring. I can see that all three of these terms have a GCF in them. And that GCF is not just 7, but -7. Remember, if your first term is negative, then go ahead and factor out that negative as well. So let's say my GCF is -7. So if I take -7 out of 28, that'd be minus 4x. Take -7 out of 35, so minus 5 equals 0. And we'll factor. Or at least try to factor. Hopefully we can factor. All right, I know this will be my general setup for what I need to do. Two numbers that add together to make -5. Or sorry, multiply together to make -5, but add together to make -4. -5 and +1. Set each factor equal to 0. X equals 5. X equals -1. Just because there's a -7 out there still doesn't mean anything. We don't need to do anything with it. We can just leave it. Because if you set -7 equal to 0, that doesn't make any sense. Okay, but I have two x values here. So let's take these two x values and substitute them into one of our original equations. It doesn't matter which one. Let's say the first one. So that green one that I had. So x squared (5 squared) plus y squared minus 4 times 5 plus 16y plus 58 equals 0. Five squared is 25. Negative 4 times 5, negative 20. So I just want to combine some like terms, all of my constants, so the 25, negative 20, and 58. So y squared plus 16y. 25 minus 20 is 5. 58 plus 5, 63. Okay, so I end up with another quadratic. And just like before, like in this one, we got down to this x squared plus 12x plus 36, and we want to factor. So we're going to do the same thing. So let's factor this and see what we get. Two numbers that multiply to make 63, but add together to make 16. Y plus 9, y plus 7. So we get y equals negative 9 and y equals negative 7. So a point of confusion that I often see. So we plugged in 5, and when we did that, we got these two answers. So that means I know two solutions. I know if I plug in 5, one thing I'll get is negative 9. And I know if I plug in 5, another thing that I'll get is negative 7. So right now I have 2 points. But that's not it, because that was only from plugging in x equals 5. We still have to go back and plug in x equals negative 1 now too. So I'll go to my same equation, and now instead of plugging in 5, I'll plug in negative 1. So negative 1 squared plus y squared minus 4 times negative 1 plus 16y plus 58 equals 0. Do some simplifying. 1 plus 4 y squared plus 16y. 1 plus 4 is 5. 5 plus 58. 63. Okay, so we got down to our same factoring. So again, I'll say y equals negative 9, y equals negative 7. So another 2 points if I plug in -1, one thing I'll get is -9, and the other thing that I'll get if I plug in -1 is -7. So I have 4 solutions for this particular problem. And that actually makes sense. So let me pull up the graph of this really quick as my last thing that I do. X squared plus y squared minus 4x plus 16y plus 58 equals 0. And then 8x squared plus y squared minus 32x plus 16y plus 23 equals 0. All right, so here's the 2 curves. So we have an ellipse and a circle that are intersecting each other. And where is it they're intersecting? -1, -7, -1, -9, 5, -7, and 5, -9, which is exactly, again, this is exactly what we found. Those were our solutions. Oh wait, you can't see it. Let me pull it up. Desmos. Okay. So there you go. There's the graph of those 2 conic sections, an ellipse and a circle, and the points where they intersect are exactly what we found algebraically. So that's all we're really doing, is finding where do these things intersect with one another, if you want to think about it in a visual sense. That's all that I have planned here. I sent you an assignment that has just like, I don't know, three of these examples to do, just to practice. They don't take a crazy long time. They're not the shortest things in the world. You know, it requires us to do a few steps and some factoring, but they're not insane. Okay, so take a look at those. Try them out. Hopefully it can go well. I'm going to start this week approving PFAs. Okay, so just kind of periodically throughout the day while I'm on here teaching and in between then and in my office hours time, I'll kind of glance through, and if I see that you have PFAs requested, then I'll approve them. So you can start going for that. Because you guys love PFAs. You do them really well, really diligently. Any questions for me? When are the office hours? Come on, man. I do an email every morning that has the office hours. It's the title of my stream. 1:45 to 2:30. All right, and so office hours, if you're explicitly wanting to ask a question about something, then great, come in office hours, and feel free to ask. Also, it's just good. I just know that that's a time where I have more available time, so I can check for PFAs more. But again, I'll kind of check throughout the day as well. So just even if I can't approve it immediately, if you want to take it, go ahead and request it. And whenever I can get around to it, I'll try usually before and after I teach, and then maybe once like in the middle of when I'm teaching, I'll check through. But just let me. Well, don't let me know. Don't like send me an email every time you request one, but request it and I'll get to it. Yeah, 1:45 to 2:30 for office hours. Anything else? The sun's killing me. Okay, I guess not. So if that's that, I'll go ahead and end class with those two examples. Again, I sent you the email that had the homework assignment. It's just like, I think three of these questions. Test them out, try it out, make sure you can do it. And let me know if you have any questions via email or in my office hours later today, starting at 1:45. Cool? Sounds great. All right. I will see you all on Wednesday. Again, so just doing A days. So I will see you guys on Wednesday. Later.